Hi, I'm David Roth, one of NAF's electrical product sales managers. And I talked in an earlier video about Industry 4.0 initiatives and the three-bucket approach that NAF takes. We discussed how most Industry 4.0 projects really center around creating a nice, sexy dashboard full of KPIs and useful data so that engineers and the users of that can quickly and easily consume what they need to. For most people, it's about increasing efficiency. Instead of taking 20 minutes to walk out to an asset to see what's going on, instead taking 20 seconds to pull up a web browser, ping an IP address, and see that dashboard. For some people, SCADA systems are the answer. However, for some they're not. SCADA systems are capable, able to handshake production data with the ERP system, with warehouse management systems. SCADA systems can cost as low as about $20,000, but then can easily rise to a few $100,000. By the time we throw in licensing and full integration costs, sometimes they can be cost prohibitive. But that doesn't mean the dream of connected systems still can't be realized. The PDR-1000 from Phoenix Contact is an easy to deploy solution that integrates alarming, trending, data collection with a nice sexy dashboard that's viewable anywhere on the network via any common web browser. The best part about it is the PDR requires configuration, not programming. Setup is done via a simple web-based interface, so the only software you need is a web browser that's already installed on your laptop. It's great for small to medium-sized end users who want to deploy Industry 4.0 initiatives but don't have the budgets for full SCADA software and integration services. The PDR is capable, it's expandable, and scalable. This controller that comes with a handful of digital I/O can be expanded to add more digital I/O, analog, or we can communicate Modbus via Modbus TCP client to up to 8 Modbus devices. We can store data locally on an SD card and download it as a CSV file, or even transfer to network storage via an FTP connection. And down the road, if a SCADA system is ever realized, we can take this controller, now he can operate as an edge device, communicating up directly to that SCADA system. This little controller is the bee's knees, it's pretty slick, and is a great way to kick off an Industry 4.0 initiative for small to medium-sized end users. Let's give it a look. All right, so the first step when we pull this PDR out of the box, get it powered on, connected, and plugged into it, we're going to open up our web browser and we're going to type in the IP address of the PDR. So the first thing we see is this home configuration screen. This is where we're going to set up and define our I/O. In our case, we added an analog input module that's going to be used to read a transducer position. So we need to define what type of module we have. So we're going to click on the image, select our analog input card. In our case, this is AI2. So this is kind of what our home screen looks like, but from here we need to further configure our analog I/O. So in our case, this is a 0 to 10 volt device. We're going to set that up. And on this screen too, right underneath where it says mode, we have something called span. This is where we can go through and we can basically scale what our analog is and redefine what that value is. So if I wanted to change that to millimeters and say that, hey, 1 volt equals, 10 millimeters and I got 100 millimeters total, like this is kind of where we can set that up. And then there's a few other options we can go in and mess with setup. So for our case, what we're going to do is we're going to set this up as kind of like a high, go, low. So our low output, whenever we hit 2 volts, when we get below that, we want to set up an output, and whenever we get above 8 volts, we want to set up an output. So then we can set up the time before that alarm goes out, and then we can define what kind of output, right? What do we want to have happen when we hit that alarm state? In our case, we're just going to signal a couple discrete outputs. Maybe that's a local alarm that could go out to a stack light. Next, we need to scale our trend graph. So we go through and define what that is. Then we need to further set up our graph settings. This is where we're going to define inputs and label our graph. We're going to creatively call it transducer and add our analog input. Now we see our home screen and we can see exactly what our cylinder position is. We see that it's red, so we're in an alarm state, and when we go too low, we get an alarm, and when we go too high, we get an alarm. Next, we can graph and trend that. So now we can see real-time cylinder position, transducer position. And from here, we can do some really, really cool stuff. We can look at local alarm screens. And we can see the historical alarms that we've set up. And then we can also do really cool things like view it historically. So when you come into work and somebody tells you had a problem on press 3, you can pull up and look at press 3 over the last 4 days and see what this transducer position's been doing. So we get better visibility into your processes so you can make data-driven decisions. We look forward to working with you on your project. Reach out to Neff, let us know what you think of this video, and let us know if we can do anything to help. Thanks so much. Have a great day.